All right. I have no idea what I'm doing with that. All right, so now let me pull this up. Yeah, minimize Zoom when you're recording this meeting. Eee. All right, hang on a second. I'm just going to pull up the homework assignment on my iPad.
Okay, thank you.
Yeah. I don't know if my speaker isn't loud. I have a hard time hearing you guys. I mean, I know Victor was muted, but I mean, even with that, I'm going deaf. All right. Holy cow, this taking forever. Can you just read me that problem while this is coming up? I feel like I'm hung up here.
Yes, it's actually, I guess, number 13, but it's problem 19.51. It says 3 resistors having resistances of R1 equal to 1.62 ohms, R2 is equal to 2.57 ohms, and R3 is equal to 4.95 ohms, respectively, are connected in series to a 27.6 volt battery that has negligible internal resistance. And part A says find the equivalent resistance of the combination.
They're connected in series.
Yes.
So how would I calculate the equivalent resistance of the combination? That wasn't just for you, but anybody. How do I calculate the equivalent resistance of the combination?
Add them up.
Yeah.
Okay. Well, I did that, but every number, it didn't matter. I mean, I don't know if it's my rounding or.
So you did that and didn't get and it wouldn't mark it right.
Right.
Oh gosh, well, I haven't heard that from anybody else. That doesn't mean it's not happening. I'll just have to check it. So okay. So what's the next question? So if you, can we just add those up real quick?
Yeah.
So it's 5.02, so 7.52, 8.52, 8.54, 9.14? I'm guessing. Can somebody add those up?
Yeah.
You said
that it's 9.14.
Okay.
I just tried that and it actually let it go through. So I don't know if I was just hitting the wrong button or what, but it was using that.
You said it took that?
Yes.
Okay. Well.
So it may have been an error on my end, and I'm sorry.
Well, it doesn't have to have been. The thing, it's occasionally goofy. It wouldn't be the first time. So, all right. So what's your next question? Well, I'm glad we got that one working.
The other question in that same chapter would be the number 4. It's problem 19.6, and it could have been. It's a 14 gauge copper wire with a diameter of 1.628 millimeters, carries a current of 12.5 milliamps. What is the potential difference across a 2 meter length of the wire? Oh no, I got that part right. It's the second part B. It says, what would the potential difference in part A be if the wire were silver instead of copper, but all else was the same? Well, I looked up the resistivity of silver and utilized that number, and I can't get it to mark it right on that one either.
Okay. All right. What was the length of the wire?
2 meters.
And so its resistance was rho times L divided by the area, and so that was whatever the resistivity for. What was the first one? Was it copper?
Yes.
Times 2 meters divided by, and if you want to leave it at the diameter, you have to say pi times 1.628 times 10 to the minus 3 meters divided by 2 squared.
Right.
It was pretty messy. Right. That would be the resistance. And so then the voltage would be it would be 0.0125 amps, right? Because I would have to move this guy over 3 places to get amps, and then I have to multiply it by this quantity, rho for copper times 2 meters all over pi times that thing, 1.628 times 10 to the minus 3 meters over 2 squared, right? Because it's pi r squared is the area.
Right.
And so then it said, what would the voltage be if you use silver instead? Is that what the question was?
Right.
So you would take the answer you got for this guy, whatever that answer was, divide it by this number, and multiply it by the silver number. Is that what you did?
Yes, and
Okay.
my answer, it keeps telling me, like, I got 1.86 times 10 to the negative 4 volts, and I tried to round with that too, and it kept saying round to 3 significant figures.
Oh
So
gosh.
I tried a couple of different things that were close to that.
Can anybody, so can you tell me what the resistivity of copper is? It's like 1.73 times 10 to the minus, I don't know, 5 maybe. What is it?
1.7 times 10 to the negative 8.
-8. Okay. And that's in is the units for that is ohms times meters, I think.
Right.
So if I
And
do all that,
silver, go ahead.
let me just see if I can get all this and get the answer that you got. So this is times 1.7. Is it 7? Is it just 1.7?
Yes.
Okay. E
Or
minus.
that's what I'm getting on the table that I pulled up.
Okay. That's from the book, from the problem. I
I
sort of
just
vaguely
Googled it
remember
real
another
quick.
digit on there, but that's okay. Let's just see what we get with that times 2.
It's actually 1.68 times 10 to the negative 8.
Probably won't matter, but
Not 1.7, but
E minus 8 times 2. So I get like 2.02 times 10 to the minus 4. Is that what you got for that one?
I'll go back to my answers. 2.02. I got a 2 point. I rounded to 2 evenly, and it didn't. It acted like it was closer to 1.86. It just kept telling me. Whenever I put in 2.01 and 2.02, it acted like it was wrong. And whenever I enter 1.86 times 10 to the negative 4, it tells me to round to 3 significant figures.
Does anybody else do this and have a problem with it?
Yeah, I did too. I had the same issue as she did, where it didn't, for silver, it wouldn't accept the answer.
The silver one.
Yeah, the copper one was fine, but the silver one, it wouldn't work.
Let me just see if we agree on what the resistivity of silver is. I don't think this is going to fix it.
Sorry, on the copper one, I got 2.07 times 10 to the negative 4.
On the copper one, you got what?
2.07. So
Oh.
that was close enough to 2.02. I was still talking about the silver one, sorry.
Use 1.68.
Yes.
See, I see in the textbook, I see 1.72, not 1.68 for that number. For the times 10 minus 8.
So for copper, I used 1.7. I rounded up, and for silver, I used 1.6.
Hang on a second. Well,
Yeah, I think I used 1.6 as well.
your book says 1.72 for this number. And that's sort of what I remembered. So I knew I thought it was over 1.7. So what I get for this is 2.07, 2.066. I mean, I don't mean to be splitting hairs here. And so for silver, according to your book, it's 1.47. And so I could, if I multiply this by 1.47 and divide it by 1.72, 1.72, I get about 1.76. That's what I get for my silver number. Have you tried that? What were you getting for that?
I was getting 1.86, but 1.77 works.
Yeah. You know, so here's what I would say
Right.
about this. The digits on these numbers probably matter a little bit.
Okay. Don't round those.
And you know, I- if we were in class, I might have mentioned this, but when you're working these problems, you ought to use the numbers that are in the book. If you don't have them, oh, well, the thing should have the ebook on there, right? So you should be able to look those numbers up. But I wouldn't just Google these numbers because, well, I don't really know why, but I've seen them in places where they're slightly different than these, and it can create the kind of problem that I think you had.
Okay, thank you.
Yeah, that's a totally reasonable question. And I don't know why it's that way, to be honest. All right, any other questions? What else? So if you guys had this problem, I would never give you numbers like that on a circuit problem like this. I think you know that already, hopefully. I'll give you rounder numbers, but you know, could you calculate the voltage across that guy? So if this is 12 volts, and this is 10 ohms, and this is well, R2 equals 20 ohms, and this is R3. Equals 30 ohms. Could you calculate the voltage across this guy? What would the current in the circuit be? I'll be right back. My guys are digesting that. So who can tell me the current through this one, the voltage across this one, the power consumed by this one? Any of those? Who can tell me the current through it?
Is it 0.2 amps?
Yeah, how do you know?
you add up, so the resistance of series equals like all of the resistance added together. So then that's 60. I equals V over R. And then so 12 divided by 60.
Perfect. The total current is the voltage divided by the total resistance, and so that's 12 volts divided by 60 ohms, which is 0.2 amps. And since it's a series circuit, everybody has the same current. And so everybody gets 0.2 amps. So this guy gets 0.2 amps, this guy gets 0.2 amps, and this guy gets 0.2 amps. And so then knowing that, what's the voltage across this guy?
$2.4.
Just across R2.
Is it 4?
Yeah. Yeah, how'd you get that?
20 times 0.2.
Ohm's law. Sorry. So what's the voltage across R1?
2.
2.
Yeah. How about R3?
3. 6.
6.
Say it again.
6.
6, right? They're all just whatever resistance they have times the total current in the circuit, whatever goes through them. Right? It just happens that in a completely series circuit, everybody gets the same current. Right? And so 2 volts, 4 volts, 6 volts, right? That adds up to 12. So what's the power through R1?
Point 4.
How'd you get that?
Power equals I times V.
Yeah. Right. And so it's the voltage, which we already decided was 2 volts across this guy, right? 2, 4, and 6. And it's got the same current he had before, right? So it's 2 volts times 0.2 amps. So I can say, P1 is equal to V1I, which is equal to 2 volts times 0.2 amps. I think this is what we did last time, right? Who can tell me what the total resistance of that circuit is?
You ask for current?
Total resistance.
Total resistance.
I'll ask that one next.
Would it be 30?
Right. How'd you do that?
For 1 over R parallel equals 1 over R1 plus 1 over R2, or 1 over R2 plus 1 over R3. So then R parallel would be 20. And then resistance of a series, you just add the resistors together. So 20 plus 10.
So this is neither, the whole circuit is neither series nor parallel. I have pieces that are one or the other. And so I have to kind of break them down. And the first thing I do is break down this parallel piece because it's kind of self-contained. And I can see that 1 over R parallel for this green boxed piece is just 1 over R2 plus 1 over R3. So it's 1 over 30 plus 1 over 60, which is 3 over 60. And so R parallel, as Victor said, is 20 ohms. And now that piece is in series with this piece. All the current that goes through R1 has to go through this thing I call R parallel. Some of it gets split up, but all of the current ends up going through this little green box. And so we can say those two are in series. And so then R series is just equal to R1 plus R parallel, and that's equal to 10 ohms plus 20 ohms. I'm way off the screen here, aren't I? And that's equal to 30 ohms, sorry. It's equal to 30 ohms, say. And so now I know the total resistance in the circuit. What's the total current in the circuit?
Is it 0.6? Or did they separate?
Close. How did you get that? What did you do?
I did 12 over 30.
Yeah, 12, isn't that point 4?
Yeah, 0.4.
Yeah, my bad. I
No.
typed it.
Great, you did it perfectly. It's just it's a math error. Yeah, that's exactly right. It's just the total voltage over the total current, over the total resistance, 12 volts over 30 ohms, or 0.4 amps. And so I is equal to V over R series, which is 12 volts over 30 ohms, which is 0.4 amps. What's the current through R1?
Would it be 0.4?
How do you know?
Because if it's in a series, then
Yeah.
it's the same current.
Everything that leaves the battery has to go through R1. And the total current is what's leaving the battery. And so everything that leaves the battery has to go through R1. It doesn't have any choice. Not all of it has to go through R2 or R3, but the total current through R2 and R3 has to add up to the total current through R1. Right. And so if I have a resistor that's in series with my battery, then whatever current gets out of the battery, which is what we calculated here, goes through this guy. So what's the voltage across R1?
Four.
Yep. Ohm's law. V1 equals I1 R1. For any resistor, the voltage is equal to the current times the resistance. And so that's 0.4 amps times 10 ohms. That's equal to 4 volts. What are the voltages across R2 and R3?
Eight.
How do you know?
You just subtract it from the total battery voltage.
That's exactly right.
They're in parallel, so
yeah, these
they get the
guys are
same
in
voltage.
parallel. All the voltage that wasn't used here goes here. I didn't have to do any calculation other than subtracting. And so I know that this is 12 volts. If this is 4, this is 8. Right? And so what's the current through R2?
Is it 0.267?
That sure looks right to me. It's V2 over R2, which is 8 volts over 30 ohms, which is
Yeah, 0.267.
0.2. I couldn't do that math in my head. Amps. It's and so what's the current through R3? There are two.
0.133.
Yeah, it's so you could say it's V3 over R3, which is the same 8 volts, except this time divided by 60 ohms, which is 0.133. Or you could say, look, 0.4 amps came in here because that's what's going through I1, right? 0.4 amps came in here. 0.267 went this way. And so the rest of it, 0.133, has to go this way because these two guys have to add up to the total current in the circuit. The water can't disappear, electricity can't disappear. And so it either goes this way or this way. And so either one of those would be a fine way to do that one. All right. What else?
Dr. Trail,
Yeah.
would you be asking us like what is the voltage on each one? We know that the whole capacitor in parallel right there is 8, but how do you do like R2 is this voltage and R3 is this voltage?
In this particular problem?
Yes.
Well, yeah, I could ask you that, and you'd figure it out the way we just did. If you wanted to, if you get a problem like this, you have to start generally by calculating the total resistance. And so if you wanted to know what the voltage was across this guy and this guy, I would start by figuring out what the total current was, and you do that, you have to get the total resistance, right? I think Victor did that for us. But you add these two up in parallel and add it to that in series, and that gives you a total resistance. And then you divide the total voltage by the total resistance, and that gives you the current. And then you can just do them a piece at a time. I don't think I'd give you a single question that would have you do all those steps at once. But every piece of that it should be doable, right? Once you know the current, first you get the total resistance. Once you get the total resistance, you can figure out what the current is. Once you know the current through this guy, you can figure out his voltage as we did here, and then subtract that from this, and that gives you the voltage across each one of these. Once you know the voltage across each one of these, you can calculate the current like we did down here. And so, you know, to me, these are like putting together a jigsaw puzzle. Any one piece isn't harder than the other. Sometimes you have to put some in before others can go in. But we're using basically all the same rules for these things. We got a handful of rules: parallel resistance, series resistance, and Ohm's law, basically, until we start talking about power, and then you've got the equation for power. Did I answer your question?
Yes.
All right.
Dr. Terrell, I have a question.
Okay.
On the last exam, I think when everyone got on to start the exam, it was a wait to get in. So I started like 8 minutes late,
Oh.
which doesn't seem like a lot, but I ran out of time at the end of the exam.
So
So are you gonna,
I'm glad you said that. I'll put some extra time in there for that.
okay,
Yeah.
thank you.
Thank you for saying that. I've been wrestling for about the last 2.5 hours with getting that thing up and not having sort of the same kind of craziness that happened to it. And I haven't got it right yet, but I will make sure that it has extra time on it.
Okay, thank you so much.
Yeah, thank you for saying that. What else?
So in one email, it said part of 23. Is this still part of 23 on this exam?
No. Sorry. There's none of 23 on this exam. I thought I put that in the last announcement, but maybe I didn't.
I wasn't for sure. I had just read back over them and I wasn't completely sure.
Yeah.
So
There's none. So this exam is over 2 chapters, 19 and 20. And I'm just going to be specific next time about what I put on the final from 23. I'm going to put up stuff so usually I get through chapter 24 in this class, and I'm not going to test over chapter 24. I don't think. I'm fully decided, but I'm very unlikely at this point to give you any. And so there'll be some questions from chapter 23 on the final. And I know right now, like I just moved the chapter 23 homework to Friday. That's going to be voluntary. And I'm just going to put out a message telling you which problems to look at if I'm going to put finals questions on there, which I will. I will have finals questions from chapter 23. And I'll try to be specific about which ones would be similar to exam questions from your final. And then I'm gonna put up some information about chapter 24 and not put it on the final or anything, but there are people who have to take the MCAT and stuff, and that's optics and lenses, and you're gonna need to know that. And so all I'm gonna say is this is what I would teach you. So as far as your grade is concerned in the final, you'll need to know chapter 23, which is the properties of light. And I've got a little more to do on that tomorrow. I put up a bunch of it, I think. There should be some of it up there, right? I think I've put a bunch of optics stuff up there. I'm losing my mind, but I'm pretty sure I have. And so I think I've got got stuff to do on polarized light left. And so does that make sense? So on this test, there'll just be these 2 chapters, magnetism and circuits. On the final, I'm going to put up some stuff from chapter 23. And so I encourage you to try to do the homework. And I'm going to count that homework as like replaces your lowest homework score. So if you don't want to do it and you're okay with your homework score, just leave it. But I'm going to I'll try to make it so that if you do that assignment, it'll benefit you on the final.
So the final is still comprehensive?
Yeah. At this point, the final is still comprehensive. You're really going to have to rattle my cage to get me out of that one. I'm not saying it's not possible, but I have I have a really hard time in this class not giving a comprehensive final. One of you guys sent me a message on that Friday, and I haven't given it a lot of thought, but my initial reaction was, gosh, that would be really hard for me to do. So I'll think about it some more. And if somebody wants to make a really good argument at me, I'm open to listening. I mean, apart from the
I have a
fact that
question
we're
about
living in a
grades.
freaky world right now. I'm sorry?
I have a question about grades.
Okay.
So I know on the first exam you said that might not be like your score, it might go up, blah, blah,
Yeah.
blah. So is there any way to know how we're actually doing in
Well,
this course?
so on the first exam, I think all I said was, you know, I usually scale things at the end of the semester. And so it looked like, I think that I haven't got the numbers in front of me on there, but I would have given maybe a 5-point curve. I think the average on that test was like a 72 or something. And you make a fair question. I haven't assessed the second exam. I'll try to have all that done this week, so you know going into the final what you need to do. But hopefully a lot of that's on your syllabus, right? You should know do you know what your lab grades are?
No.
Okay.
Okay.
Well, I have all my labs like with me at least.
Okay, so then you should know what your lab percentage is, right? Those count for an exam. And so, I mean, even if you're just ballparking it, if you made 90 or 95% on your labs, that's what your lab score is, right? You should be able to figure out what your homework score is, right? What percentage you have on the homework. And usually I curve that a little bit. Usually most of you guys are doing pretty well on that, because I have a bunch of extra credits every week. So you can get bonus points on them. And so you should be, most of my students get 100% or close to it, in the high 90s on the homework and in the mid to high 90s on the labs. And so I give everybody, unless you haven't like participated in most of them, if you've skipped most of the learning catalytics, you will not get all the 50 points. But usually that's like 2 people in class, maybe something like that. Everybody else gets those points. So I think you can work out your grade, right? If you have both of if you have your lab grade and your homework grade and the learning catalytics, you have one exam grade. I know the second grade is wonky, and I'll have that for you in a few days. I keep saying that.
Yeah, you kind of answered my question, because on the syllabus, I was kind of unsure on how the homework and learning catalytics was split up, because it just says it'll be split.
Oh,
So I was just confused because I know.
got it. Yeah.
You know what I'm saying? And I know we had talked about it before. I had trouble with the learning catalytics, so I was worried that because I didn't those first 2, it would hurt you. Anyway, that's all I was asking.
Okay. Well, I'm glad you asked.
Hopefully that makes sense. I'm sorry.
Yeah. I'm glad you asked. I'll try to let you know what you need to do on the final, or give you a sense of how you need to do on the final to, if it helps you any, I'll probably grade significantly easier this semester than I ever have. So, I can't make any promises, but I'll certainly be kinder this year than I've ever been before. So you guys should feel lucky from that standpoint. Everything else has been miserable for you, I know, but I'm going to try not to punish anybody for the craziness of the semester.
I have a question.
Okay.
So you usually give back our tests, but this last one was online and we can't look at it.
Oh, yeah. Thank you for asking that. I will post a version of that with the solutions. Would that be good?
Yeah.
Test 2 solutions. Yeah, I'll do that. Oh yeah, it doesn't let you look at the answers on there.
Well, I didn't check. I just assumed since it was on lockdown,
Oh.
I can look.
I'll check it. I'll check it. I'm not going to check it today. Probably not tomorrow. I'll check it Tuesday. I'll get to that on Tuesday, probably.
Yeah, it says the correct answers are hidden.
Dr. Trail, could you also post the circuits answers,
Say that again.
the answers to the circuits learning catalytics?
Is that not on there?
No, it was just the learning catalytics, not the answers.
Let me see. Okay. So after we're done here, I'll post, hopefully, if I have it. I think I have it. We did all of those in, I think we went through every one of those, if I'm not mistaken, in the classes, but yeah, in the Zoom sessions. But yeah, I'll try to get those up when we're done here. What else? You guys have a lot of questions. It's good.
I think it's because we're all just really confused this semester.
This has been a crazy semester, I will say. Yeah. Yeah. Other people have bigger problems than at least than I do, but it's been pretty crazy. All right, is that it?
I have a question. Oh, sorry.
Somebody send me an email on this test 2 solutions, because that'll make me get it up. That's the one I'm worried about. I'll do this right after we're done here, but I'm gonna have to dig this out, and I've got other fires to put out this evening. So if you'd send me an email on that, that would be great. What was the other question?
This is like a future question for like maybe in the fall if we get to come back. Would you consider like doing a like evening study session of some kind for those of us that do want to take the MCAT?
I'll do that anytime you want it to do it. We can do it over Zoom.
Okay.
Anytime you want. And I know you were asking me guys. You guys were asking me at the beginning of the semester, and I would or sometime. When would you guys come by my office? Anyway, I would be delighted. I'm not teaching this summer, and so I'll have a little time. And whatever you guys want me to do, I'd be happy to do it. And it'd be great because we could go over the optics, which that's what worries me here, is that you guys are going to have to go take these standardized exams without the lens and mirror stuff, which is sometimes what they put on that. So yeah, I'm delighted. I'd be happy to.
Thank you.
Yep.
Psychology department did that, and it kind of, I think it helped a lot of people. So
Good. Yeah, I should do that. I should do that every semester. And if we can come up with some kind of format, that'd be great. That'd help me a lot. But yeah, let's do it. All right, are we done? All right. I'll have this thing up. I'll give you extra time in the morning to get ready so you're not crunched. Get in as early as you can, and stay till it ends, I guess. Does anybody have a 9 o'clock tomorrow?
Yes.
Okay, that's the catch.
Yeah.
Is anyone opposed to maybe starting it earlier then?
I'm good with that.
I'll tell you what I'm going to do. How about if I start it at? I'll start it at 7:45, and everybody's on their honor to take an hour, and you can jump in whenever you want. How about that? Because it's not fair for me to give some people more time than others because of the circumstances of their other stuff. I would give everybody extra time, but I realize that if you've got a 9 o'clock class, I can't do that. Is everybody okay with that?
I think that works.
All right. I'll try to start it at 7:45, and you just get an hour, and I'll just trust you guys take an hour. All right. All right. Good night, everybody.
Good night, Dr. Trail.
All right. Thank you.
Thank you.
Thank you all.
Thanks, Dr. Trail.
Thanks. All right, answers to circuits. Let me dig that up.